Now, so those that have joined us, so we are still on streams, okay? And in particular, int streams, double streams, and long streams. These are streams of primitives, okay? Go briefly through them again. So here, you can't create a stream of primitives from a list. Why? Because a list is a collection of wrapper. It's a collection of objects, okay? And for instance, DoubleStream is a stream of primitive doubles. So you can create a double stream from an array of primitives, okay? So I have an array here called D array, and I got double stream of D array, okay? Now, the advantage of using int streams, long streams, and double streams is that you can use these guys, okay? They're specialized reductions, is the best way to describe them. So you can call sum. Sum is going to get you the sum of these guys, okay? We can also do average. Average is going to get you the average of these guys, okay? Now, sum returns, if it's a double stream, sum is going to return a double, okay? If it's an int stream, sum is going to return an int. If it's a long stream, it's going to return a primitive long, okay? Now, average. Average always returns something called an optional double. Now, it's not an optional of type double, so what's the difference? Morning, Roland. So the difference is there's a pin. Is there a pin there? Jeez, I don't know where this pin. So I got a pin there. Okay, this working. All right. Now, so average for returning something called an optional double. Okay, now that's an optional for a primitive double, okay, which is different from this guy. This is an optional of type double. Okay, so this optional has a generic. When it's a generic, that means that's an optional for a double wrapper. Okay, so there's an optional double, there's something called an optional int, and there's an optional long. Now, an optional long is an optional for a primitive long. An optional double is for a primitive, is an optional for a primitive double. An optional int is an optional for the primitive type int. Okay, now there is no such thing. So when you're doing sums, okay, when you're doing sums on int stream, a double stream, or a long stream, it's going to return a long, a double, and an int. When you're doing an average, okay, so what's an average? It's going to be the average. Got this guy here. So we created the stream from these numbers here. Okay, so average, doesn't matter whether it's you're using a double stream, an int stream, or a long stream, the answer is always going to be an optional double. Yes? So you'd have 4 3 plus 3. Okay, that's going to be 10. So the average of those three numbers is going to be 3.3333333. Yes? Okay, doesn't matter if they're ints, doesn't matter if they're doubles, doesn't matter if they're longs. The answer is always going to be 3.3333333. Okay, now you can cast that number, of course, to be an int. If you cast it to be an int, it becomes 3. Okay, now there is also a function, I don't know if we ever used it before. It's this guy. It's called math.round. Okay, now I don't know, it's not an exam, it doesn't matter, it's just a handy function to know. Now what math.round does is whatever number you put in there, it's going to round it to the nearest whole number. So 3.6 would become 4. Okay, 3.33 would become 3. Because when you're casting to be of type int, let's say your answer is 3.999999. It's only 0.000001 away from 4. So it's a lot closer to 4 than it is to 3. Do you understand what I'm saying? So if you use math.round on that number there, it's going to give us 4. Whereas if you cast that number to be an int, it's going to give us 3. It's a lot further out. All right. So that's just aside. I don't know. I don't think examinable was just a handy thing to know. Math.round is a handy enough function to know. Okay. Now, so here I create a double stream of the array. It's these guys here. Okay, then I get the average. Now the average returns something called an optional double, which is not a double. That's the way it's going to be. Now you can't use that in calculations. So if you want to use it in calculations, you have to say get as double. So that'll return the number 23.9872. Okay, now there is other methods. So you can get, now the reason it's an optional for, so sum of an empty stream. Okay, so if you have an empty stream of ints, if you sum it up, right, you're always going to get some number. Even if there's nothing in the stream. If you sum up an empty stream, you're going to get 0. Does everyone understand that? Yep. Now, an average. You can't get an average of an empty stream. All right. That's why the average method always returns an optional, or in this case, an optional double. Okay. An average always returns an optional double for int streams, double streams, and long streams. Okay. So it'll always return. So you can see here, opti.empty.average, that is going to return, no, that returns, put it out here. So up here.
No, you put in double column or
Yeah.
opt-d.
Yeah.
Actually,
Opti, it just says optional double.empty. Okay. So now if you're in doubt that you're optional, because your optional may or may not have a value. Okay. Your optional may or may not have a value. So what you can do is, now you can use, just again, get as double. So optional double is a double. Now there is no get function method. There is something called get as double, which we can see up here. Okay. Now that's fine when you have a value. If you don't have a value, for instance, if I go here, I am Biggie. Okay. So if I go here and opt ID is empty at this stage. Okay. Dot get as double. Okay. Now we get no such element exception. Okay. Why? Because opt D is empty. All right. Also, if you have an infinite stream, all right, if you're trying to give an infinite average of an infinite stream, it's going to keep on going forever and ever. Because what it's doing is it's checking all the numbers, and the numbers go on forever, so it's going to check them forever. All right. So this will generate no such element exception. Okay. Now, the thing about these double streams, in streams, and long streams, all the operations of the ordinary streams are also available to it. Okay. Now, if you're doing a lot of operations on it, let's say you have 7 or 8, you have 2 or 3 filters, you have 1 or 2 maps, you might have a flat map in there, you might be doing all sorts of mad shit inside it. Okay. At the end of it, you're not too sure, is there actually going to be anything there? All right. You're taking an input from a user, you're filtering it out until you get only certain conditions. So at the end of it, there might be nothing there. Okay. That's why options are used a lot in streams. Because there is going to be situations when your stream produces nothing, which is valid. Okay. So now, rather than use get as double, we can use or else. Now, or else, so this is an optional double. So or else, so if this has no value, we're going to use the value 0.0. Okay. Now, or else get takes a supplier object. So what this is, so supplier takes in nothing, returns an object. Now, this is in stands for not a number. Okay. Now, the reason you would use that is if you use not a number in any calculation, your answer is always going to be in. Now, it won't cause your program to crash. All right. So this is more is to show you there's some problem with your code. Okay. If you're doing all your calculations, and if at the end of your calculations, your answer is not a number, that means somewhere in your calculation, it used not a number. If you add up 4 numbers, and then you try to multiply it by that guy, your answer is going to be not a number. If you add up 2 numbers, multiply them by another number, divide them by another number, get the modulus 2 of all of that, and to the power of 4 plus not a number, your answer is going to be not a number. Okay, so if you use not a number anywhere in a calculation, your overall answer is going to be not a number. Okay.
What point do you use this?
Wait.
Like any calculation, like removing and everything, you get involved with.
Well, then you can see there's something wrong with your calculation. If you put in 0.0, you're going to get a number. All right. So I only want this to happen if there's something wrong with my calculation, or if there's something wrong with my logic. So you're not going to get a number at the end of it. If you use 0.0, you're going to have a number at the end of it. And it might be hard to trace back. You might think, oh yeah, my calculation is fine. Whereas if you have not a number in it, you know for certain that your calculation is not fine. I'm talking, so because if I add a number to that, I'm going to get a number. If I add a number to that, I'm going to get a not a number. It's a way of tracking that there's something wrong with your calculation. That's what's for. Does it make a difference? Doesn't make a difference. Because hexadecimal and binary are numbers. Okay, so if this, so what we're saying here is if that doesn't have a value, it's going to be not a number. Okay, and also it won't crash your program. Get as double. If it doesn't have a value, will crash your program. this guy here will produce a number that might be the wrong number, whereas this guy here is going to produce not a number. So you know that your optional has no value. All right. Now, opti double stream of array. So, or else, same thing here, or else get. Okay. So as I said here, 1 plus double dot in a in multiplied by 12, that'll always be n. Okay, that'll always be not a number. All right. Now, where's next? So you can use iterate, and you can use generate with streams, with double streams and Intstreams. So here, I created a double stream called random ds, and it's quite simply double stream dot generate met dot random. So that's going to generate. So this guy here generates an infinite stream of random numbers. So this guy here limits it to 5, and this guy just prints it off. You can also use iterate with Intstreams, double streams, and long streams. Operates the exact same way. Double stream dot iterate. So you start off with 0.5, and this is going to keep dividing by 2, and it's going to limit it to 4. Okay. So that is a stream called fractions. So then we can go fractions.peak.sum. So what that's going to do is it's going to display all of these guys. So it's going to display 0.5, 0.25, 0.125, and 0.07. Let me see. Whatever. Okay. Whatever it prints off. Okay. Now, top. So fractions, yeah. It's 0.5, 0.25, 0.125, 0.0625, 0.9375. Okay. And here's another double stream, so I can put them all on one line. So double stream dot iterate, it's going to denum, this is the number it takes in here, and it's going to return denum multiplied by 2. Okay, so it's going to keep multiplying it by 2. So it gets 2.0, 4.0, 8.0, 16.0, 32, 64, 128, 256, 512, 1024. Okay, and then it prints them off. Now, so this is the way to generate 5 random numbers between 3 and 30, not including 3 and 30. So Intstream.generate. So int num is going to be a random number between 0 and 100. Okay. Then, if the number is produced is less than 4 or greater than 29, it's going to run it again. So this will ensure that only numbers between 3 and 30 are produced. Okay. I want to make sure they're distinct, and then I'm going to limit them to 5. Now, yesterday I said that range and range closed could be used instead of that. That's not exactly true. Okay, it can be used to do that, but it's even more awkward to use than that. All right. So range and range closed isn't really a replacement for that. Okay, I made a mistake when I first was doing this out. Now, what range does, okay, so here I go Intstream.range 4 to 30. Okay, range takes an int, which is the number we start from and will be included, and takes a second, and this number goes up to but does not include. Okay, so this goes from 4 to 29 but does not include 30. Okay, so this goes from 4 to 30. It's using range to print and range, but not so. So it will. Oh, let me just see what it prints off. I'm fucking getting totally mixed up here now. Hold on a minute. Yeah, hold on a second now. So this is range. using range to print in range 3 to 30. Okay, this is 4 to 30. Okay, I'll change that to 3. So using range to print from 3, so but including 3, but not including 30. Okay. Now, huh? No, that doesn't sound right. That doesn't sound right at all. That doesn't sound right at all. Okay, so we will go up here. Now, so using range to print in range from 3 to 30, including 3, but not including 30. Okay, so go up here. So we start at 3, and it goes, so this is using range, right? And it goes all the way up to 29, but does not include 30. Okay, now that's that one. So this one here, this is going from 4 to 30. Range closed includes both 4 and 30. Okay, so starts off at 4 and goes all the way up to 30. So range includes 3, but does not include 30. I'll change this to 3 to keep them the same. Okay, range closed, including what 3 and 30. Right, range closed, that's going to start off with 3 and go all the way to 30, and then we're going to sum them up. Okay, now you can use this to pick 6 numbers between 3 and 30, but it's awkward. All right, this is actually easier. All right, you can use range closed, but this is actually easier. I thought you could use it. You can, but it's awkward as hell. All right, so that is actually easier than using range closed to get 6 numbers between 3 and 30. Okay, so range closed will use plus 3 and 30. Range will start at 3 and will go up to 30, but will not include 30. Yes? Okay. Now, then we showed you how to change from a stream to a Intstream, or a stream to a long stream, or a stream to a DoubleStream. Okay, so I created a stream of strings. These guys: penguin, seal, dolphin, whale, fish, shark. Okay, then we get which is that guy there. So it's string stream.peak. Now that'll print them all off. Okay, go to here. Now, so this is this letter. Okay, now that is a stream. So it starts off as a stream of strings. We do a peak on it, that produces a stream of strings. Okay, so this is still a stream of strings. Now, if you want to change a stream to an int stream, you use map to int. If you want to change a stream to a double stream, you go map to double. If you want to take a stream and change it to a stream of longs, you go map to long. Okay, now map to long takes, or map to int takes a function. Yeah, it's a function, just make sure that it is. Yeah. Take something called a mapper. A mapper is, now we haven't done these guys yet, to int function. Okay. The easy thing to say is that map to int takes a function. Okay. So what that means is it takes in an object. All right. Takes in an object of type string and it returns an int. Okay. So map to int takes, the easiest thing to say is it takes a function. Okay. That function takes in an object, returns something. Okay. Now, in this case, it takes in, it's a special type of function. Okay. So check this out. So map to int takes in a something called an int function. Now we won't be covering it. Yeah, we'll be covering it in not the next EX3, it's in EX4 we'll be covering it. Takes an int function, which is a function lambda for int, in that it takes an object and returns an int. Okay, so in this case, it takes a string and returns the amount of characters in the string, which is an int. Okay, so map to int takes something called an int function, which is a function, but it's a function for ints. Okay, remember what a function is from our functional programming? A function is something that takes an object and returns an object. A bifunction is something that takes two objects and returns an object. So an int function is something that takes an object and returns an int. All right, so map to int takes an int function. Map to double takes an object and returns a double. Map to long takes an object and returns a long. Okay, so here map to int, it takes in x is the string and it returns the length of that string. Okay, so we go map to int. So this is now an int stream, and the first number is going to be 1, 2, 3, 4, 5, 6, 7. Then we're going to have 4. Then we're going to have 1, 2, 3, 4, 5, 6, 7. Then we're going to have 1, 2, 3, 4, 5. Then we're going to have 1, 2, 3, 4. Then we're going to have 1, 2, 3, 4, 5. So just to show you what printing out. So I'm going to put out here our strings and the length of the strings. Now they're all in one line, okay? Because I have print and not println. Okay, see that there? I have print and not println. Put in that guy there. So we can see penguin 7, seal 4, dolphin 7, whale 5, fish 4, shark 5, and the average amount is 5. Now, average.get as double is going to return a double. So what do? I cast the whole lot of it to be an int. Okay, so the average length of, now if I take out this guy, no, I won't bother, I'll leave it there. Okay, so what you're getting there is strings and the amount of characters in each string. Now if you were to accomplish that with a loop, it's a lot more difficult. All right, now you can't create, as I said before, you can't create an int stream or long stream or a double stream from a list. Okay, so what do I mean by that? I'm going to create a list of integers. And I'm going to go list numbers. Now I'm going to use a stream to generate the numbers, stream.generate. And I'm going to do cast them all to be ints. I'm going to go math.random multiply by 100 plus 1. Hold on a minute now. So stream.generate int.math_random by 100. So that's that guy. And then that guy. One more. Fuck yeah. Do it outside it. Okay. Put this inside it. Multiply by 100. And so I put all of that inside here. And dot. Okay, what's wrong with that? And I do dot. Hold on a minute now here. There's something funny going on here. Right. Why is that giving me an error there?
You haven't got the brackets here, the brackets at the generation.
Oh, well, you're. No, because.
So I thought you had the DR would have
Oh, yeah. Jesus Christ, yeah. So, yeah. Sorry. So it's supplier. Yeah. Jesus Christ. Right. So, God. So that's going to generate a list of numbers. Okay. Now, I can't create a in-stream from that. Okay. You can't create an in-stream from that. But what you can do is you can do this first. So I can't go, for instance, numbers dot in stream. Okay, that just doesn't work. Okay, or you can't go numbers dot stream. All right, now, so let me just go here again. So I go numbers dot string. Now, what you can do here, of course, is you can go map to int. Okay, you can go numbers.stream map to int. And all I'm going to do here is I'm going to take in a integer and I'm going to return an int. And then I can, for instance, I'm going to peek them. So it takes a consumer. So dot peek, it's not dot println, it's that guy. And then I can go dot sum. Okay, so what is this guy doing? So you can't create a stream. You can't create an int stream from a list. But what you can do is you first create a stream from the list, and then you use map to int to create an int stream from that. Okay, so I'll put this here. You can't create a int stream from a collection object. Collection object is a list, set, or a queue. Okay. However, what you can do is first create a stream from a collection object, which you're allowed to do, and then use one of the mappers to create your Intstream, DoubleStream, or LongStream. Okay, in this case, we use map. We take our numbers list of integers and create a stream. Then we use map to int to create a int stream from this stream, and we can then use all of the methods of the int stream class, Intstream interface class. Sorry. Okay, so you can sum it, you can average it, you can do whatever you want. Okay, so I'm going to put this in a print statement. So what are we doing here? This is, take out that guy, put in here. So this is taking our 15 taking our 15 random numbers in a stream and converting them to a int stream. So you can't do it directly, but you can do it indirectly. All you have to do is you create a stream first, and then you use map to int with it. Okay? You can't use map to int with numbers. Just to show you. That doesn't work. Okay? You can't create something called an int stream from numbers. There is no int stream method. Okay? So you have to create a stream first, and then you use map to int. Okay? So do that. So we have our 15 numbers. So taking our 15 random numbers in stream and converting them to an int stream. So we have 35, 91, so they're all there. I want to make them distinct as well. So let's say stream.generate dot distinct. And And let's say as well, I want to filter them to be only even numbers. So that. So it takes in the object, and then it's only going to return x modulus 2 equal to 0. Oops. It's that. All right. So there we're producing 15 distinct numbers that are all going to be even, and they're going to be less than 100. All right. And that's not that difficult to read. It's a lot easier to read than a fucking loop. All right. Because this guy is generating our numbers. Okay. This guy is making sure they're distinct. This guy is going to only allow even numbers, and we're only going to have 15 of them. And then it adds them to a list. Collectors to list, which is assigned to numbers. Okay. So it's relatively easy to create fairly complicated stuff. All right. So this should produce only even numbers. There they all are. And I want to make sure as well that it doesn't use 0. Okay, stream.generate int.mat random distinct .filter .limit .collectors to list. We have our list of distinct numbers between 1 and 100. And then I come along here, numbers.stream map to int.peaks. So I'll put this on separate lines. Peak is going to print out the numbers. This guy here is going to sum the numbers. So this is the stream. This is now an Intstream. Okay. And so this is still an Intstream. Now, a really difficult question if they asked you there is, how many streams are created there? So that's one stream being created. That's a second stream being created. That's a third stream being created. Now, the terminal operation doesn't create a stream. What it does, it runs all of the code and it closes the previous stream. So if you're asked there how many streams are created, the answer is 3. Just like up here, this creates one stream. That's one stream, 2 stream, 3 stream, 4 stream. Now collect does not generate a stream. What it does is it generates as a list, okay? And it closes the previous stream. So there is 4 streams. All right, so it's not one stream, it's a collection of streams, but you read it as one. Yep. But as I said before, you don't usually modify the numbers with the peak. You use filter or for each or something else. Okay. Now, yeah, it does make a string. Yeah, it does make a string. Okay. All intermediate operations make a string, and it closes the previous string. Whereas a terminal operation usually doesn't make a string. It closes the previous stream and it runs all of the code. The code doesn't run until it gets to sum. The code doesn't run until it gets to collect. You can only have one terminal operation in a stream. If you have more than one terminal operation, what happens is, if I try to put terminal operation after this one here, so let's try to put for each. Actually, no, that one will work. Hold on. Now, collect. Okay. Now, collect is a terminal operation. So if you try to put another terminal operation after it, it's not going to work. Okay. What other terminal operations? Geez, I'm forgetting a lot of them. So let me just see another count. Okay. So if I do that, so that's the end of it. Okay. If I go dot count, won't even compile. Now, that's because collect. So collect returns a that returns a list. Okay, collect returns a list. Sorry, returns a collection object. So what collection object does it return? It returns a list of integers. That's what it returns. So collect returns a collection object. So you can only call methods of the collect class after that. All right. You can't call any methods of the stream class. So what sort of methods are available to us? Dot add, add all, contains, equals, and they're all methods of the list interface. All right. They're not the methods of the string class. So yes, you can call methods after it. But you can't call any methods of the string class. Why? Because collect returns a collection object. In this case, it's a list of what? Integers. Okay.
You know how you can continue mapping to different streams all the way down the line?
Yeah.
Can you ever get back to stream?
Right. So you want to get from a primitive to a string. Yeah, you can. Right. So that's the next thing actually going to do. Okay. So we will have a primitive. So I'm going to create a Intstream. Okay. And I'm going to call it ranges. So I'm going to say int stream dot okay, Intstream ranges, which is fine, is equal to intstream dot range. I'm going to say range closed. It's going to go from 3 to 20, and we're going to filter that out to only have odd numbers. X modulus 2 is equal is equal to 1. Okay, now, so what's that do? That's going to only produce odd numbers between 3 and 20. Yes? Okay. Now, and it's also going to include, so 3 and 23 is an odd number. So 3, 5, 7, blah, blah, blah. Okay? So this is only going to include odd numbers. So you've got an int stream of odd numbers. Now, I want to change that back to a stream. Okay? So I can go ranges dot, it is map to obj. Okay? Now what that does is it takes in an int and converts it to an integer. Okay? How does it know it's an integer? It knows it's an integer. Actually, no. Peak. So I'm just going to print them out. And I'm going to use collect. And I'm going to go collectors dot right. Now, range is mapped to obj.peak. You can't use .collect with a Intstream, okay? And so that proves, so and what I'm going to do, I'm going to go list integer. I'm going to say list integers is equal to that guy. I'm going to peek it out, and then I'm going to collect. Now, so what I'm doing here is, so I'll put in here, so converting from int stream to stream of integers. Run it. Right, so it's only having, I'll say it here, 3, 5, 7, 9, 11, 13, 15, 17, 19, which is correct, okay? 3 is in it. Now, so what's happening here is ranges, it's using map to obj. Now, what that does is it's taking in an int, okay? And it's returning its wrapper equivalent. That's all that's happening there. And to prove that it is working, I'm using collect here. Now, if this was a stream of integers, collect wouldn't work. Just to show you. If I go ranges dot collect collectors dot to list. Okay, see that there? You can't use the collect method on an int stream. You can use the collect method on a stream. All right, so you can't call collect on a, you can't call collect on a stream, an int stream, a long stream, or a double stream. What you do is you convert it into its wrapper equivalent. And how do you do that? You use map to obj. So what I've done here, map to obj takes an int function. Okay, so it takes in a int and it returns an integer. Okay, it takes in an int and it returns an integer. So I don't know what I'd say about that. So can you convert from a stream to an int stream? Yes, you can. Can you convert from an int stream to a stream? Yes, you can. If you want to convert from a stream to an int stream, you use map to int. If you want to convert to a double stream, you use map to double. If you want to convert to a long stream, you use map to long. And by the way, you can put in anything you want in there. So that'll take in your int and it'll produce a int stream that's going to be double your numbers. Okay, so it doesn't have to be just X. That will be double the numbers. Okay, doesn't change the original list. Numbers is still going to be whatever those 15 numbers are. But this stream is going to contain double all of the numbers. Okay, so map to int, map to double, map to long. That's for taking a stream of objects and converting them into a stream of primitive ints, a stream of primitive doubles, a stream of primitive longs. If you want to do the other way around, you start off with an int stream, a double stream, or a long stream. You go ranges, map to obj. A map to obj will work for both double streams, long streams, and int streams. And all that's happening there is it's taking in an int and it's returning an integer. Okay? So ranges.mapoj, this produces a stream of integers. Okay, so from that point onwards, you have a stream of integers. And this one here, add it to list. Is that okay?
Just a quick question, like, say what figure exhaust range flows 320.
Mhm.
Could 3 be 2 there?
Sorry?
Could that 3 be 2, or does it have to be the condition? Say 320.
Well, it can be any number you want it to be.
That 3 could be 2.
Yeah. Could be 2, but that won't be included in our final list
Yeah, that's okay.
because we're filtering this out. Yeah. No.
Item has to match the-
No, no, it doesn't. Okay. So that's from 2 to 20. So our first item is still going to be 3. Okay. Now, so that is static void ex2. We're going to go on to static void ex3. So I'm just going to go over options again. Now, so up here. So this is using optionals with primitive strings. So this is just going over optionals again here. Now, I'm just going over optionals again because the next topic we're coming on to something called statistics. All right, so we just have to make sure we know options before we go on to them. All right. So this guy. Opt double is equal to optional.of 3.45. Okay. Now, so this is a optional for objects. Okay. We have to give the optional a type. If we don't, this will be a optional of type object. Okay. So if I did the same thing, optional opt no value or opt no type is equal to optional.of 3.45. That's going to be an optional of type object. Okay, so this is an optional.
No, could you go there, line 328, and just say, instead of the option log, just equal 3.45?
Say take out the double.
No, on the right hand side.
Take out that entirely.
No, on the right hand side, where you got that legal side, just say equals 3.45 rather than option log.
No. No, can't do that. Okay, because it's not a number. There's all sorts of things going on in the background. Okay. Now you can use, so optional of 3.45. Now it's the same way for, so that is an optional of objects. So when you're using an optional for objects, you have to, if you don't supply it with the type, it's going to be an optional of type object. Okay? So if you don't supply a type,
Object,
yeah,
in the comment there.
yeah. So if you don't, this will be an optional of type object.
Yeah, below there, where you're typing in.
Oh yeah. So, sorry. So this one here. This is an optional of type double. So this is an optional of type object. Okay. If you don't supply a type, this your optional will be of type object. And you can use to get the value. So this one, opt double, will just print off. So ex3, so to main. Okay, so now opt double. Now that is option 3.45. So that is that's not a number. So if you want to get the number, you go opt double dot get, which will get the number. The problem with using get is if it has no value, it's going to get an illegal argument exception. I'll just show here. So opt double is equal to optional dot empty. Okay, so if I use a get on that, we get a no such element exception. Okay. Okay, so instead of using get, we use opt double dot or else, put in another value, 0.0, or we use opt double dot or else get, and it's a supplier, so we will get a random number. So I'm going to, so it's math dot random. So close that guy, that guy, that guy. Okay. All right. So if it doesn't have a number, generate another number, or you can put in double dot in a in. So we get in a in. All right. Now, so now optionals with so they are optionals of type, whatever type. Okay, they are optionals for objects. Now we have optional doubles, optional ints, and optional longs. Okay, so I'm going to have a stream of an Intstream, and I'm going to call it stream is equal to Intstream dot range closed. I'm going to go between 10 and 20. It's going to include, so 10 and 100. I'm going to go dot filter, and I'm going to go, it's going to take in, I'm going to say number n, and it's going to be n modulus 10 is equal to 0. Now, what am I doing there?
Only 10, 20, or
Yeah.
30.
Yeah. Okay. So it's only numbers that are divisible by 10. And we'll make it a bit more interesting. We'll say divisible by 15. Okay. So you'll have 15, 30, 45, 60, 75, 90. Okay. So as this produces a stream of numbers divisible by 15 and less and between 10 and 100. Now, so we're going to get the average of these guys, okay? So what are the numbers that are being produced? The numbers that are being produced are, we'll do it out first, okay? So if I go stream dot, I'm going to peak, okay? I'm going to have a look at them all. And then I'm going to go average. Now, that produces an optional double, okay? It's not an optional of type double. It's something called an optional double, all right? So OP, and I'm going to call it OPTDBL. Okay, so put in here average returns and optional, so it's all one word, double. Okay, now this is a different data type to a optional of type double, okay, as this, which is for wrapper double objects, and optional double is for primitive doubles. Okay, so optional type double is for wrapper double objects. Okay, now an optional can be any type. You can have an optional cats, you can have an optional human, you can have an optional string, you can have an optional string builder, you can have an optional list. Okay, whereas optional double is only for one data type, primitive doubles. Yes, so it's very narrow. So optional double OPDBL stream.peak.average. Okay, so print this off here. This is use optional double. That's all one word. Now here are our numbers. Our numbers are 15, 30, 45, 60, 75, and 90. Okay. Now, okay, right. Now, that average is a terminal operation. Okay. So this closes the string. All right. So our closes the stream. So you can't perform any more operations on the stream. But so what this produces an optional double. So optional double itself can call get as double or else get or whatever else. Okay. So average is a terminal operation. And closes the stream. Okay. But opt double itself, we can print it out. We can go dot get as double. We can go opt dbl dot or else double dot in, or we can say opt double dot or else get. We're going to produce a takes a supplier. So I'm going to say math.random. So you can do all the operations of the optional double class on it. Okay, so the stream is closed. But you can do all, but you can call all the methods of the optional double class on the variable opt dbl. Okay. Now, you can produce infinite streams with in streams. I'll just do an example of a long stream. Okay. This is a long stream, so I haven't showed you one. They're exactly the same as the double and an in stream. So this is a long stream. So long stream, I have to import it. Range closed, filter. So it goes from 1 to 30. It's only going to take those that are divisible by 3. So we have 3, 6, 9. So it's going to go up in threes. Okay, 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Okay. So again, I can go optional long, opt long is equal to longs dot max. Okay. So that's going to go up to the maximum number. And I'll do the exact same thing again here. Opt long dot get as long. Sorry. Opt long. And opt long dot get as long. Opt long dot or else long dot in. Yeah, there isn't an in for double for that, so we'll say 0.0. Oh, that's wrong as well. And or we can go last one, opt long dot or else get. And we just go math.random, and I'm going to cast, I'll put this let here, and I cast that to be a long. Okay. And there's our long. Okay. All right. Nothing too difficult. Now, it's just important to remember the following. Okay. So just like an ordinary stream, a int stream, long stream, or a double stream can produce infinite streams. Okay, exactly the same way. So if I do something like this, so we print off this guy. Now what's pi? What's pi? Yeah, 3.145926535897993. Okay, and by the way, that number is infinite as well, believe it or not. They've calculated to a couple of trillion places. So it's a universal number, all right? So if we just print that off, it's going to print off that, okay? Now, so if I do something like, so math.pi produces a double, right? So I am going to create a double stream. I'm going to call it pies. Okay, is equal to, I go double stream dot generate. Now, what I'm going to do inside this here is I'm going to go math dot pi. And after that, I'm going to have a for each. Oops, shit, I can't do that. Because for each returns void. Fuck off. Right. So if I then go P, now that's actually that's piss. I don't want to call it piss, so I'll call it something else. I'll call it doubles. Okay. Now I got doubles dot for each, and then I go just print off them off. What's that going to print off?
All the time.
Yeah. So there we are. It's an infinite stream of pies. Okay. So, so this will produce an infinite stream of the number. Let's go. All right. So we'll comment that out. Now, so max, min, average, and sum, they are all final they're terminal operations. Yeah. So once you do a max, you can't then do a min, or you can't then do a sum, for instance. Okay. So longs.max, for instance, up here, I go longs.max I can't then go okay, because java.lang illegal state exception. Okay, so we can't do another operation on that string or on that stream. All right, so put it in here. This is a terminal operation. Okay, so that closes the stream longs. Okay, so we cannot perform any more operations on this stream as the terminal operation max has already occurred on the stream. So this generates a legal state exception. Okay, so I'll comment that guy out. Now obviously, if you've got a stream of something, if you've got a stream of numbers, you might want to get the min, you might want to get the max, you might want to get the sum, you might want to get the average, right? And if I wanted to do that, that means I'd have to create the string each time. Okay, so if I wanted to use min on this string, I'd have to recreate the stream again. All right, so if I wanted to use min on this, so if I want to use min again, to use another operation on the stream after it is closed, you will have to recreate it. Okay, so I'd have to do this here. Recreate it again, and then I go longs dot min. Okay, so now obviously when you're doing long list of anything, you might want to get the average, you might want to get the max, you might want to get the min, you might want to get the sum. Okay, you don't want to have to recreate it every time. You can do it, but it's easy to accidentally not include the recreation of it. All right, so now you can't do longs dot min and then do a long, sorry, I'll change that to max. Okay, you can't do one terminal operation after another. All right, so you can't just do max, min, average all in a row. But what you can do is you can create something called a, what's the fucking name for it? A summary statistics object. Okay, so static void ex4. Okay. So these are, the correct term is summary statistics. Right. So just to show you the problem, I want to go int stream ints is equal to int stream dot range closed. I've got 1, 2, thousand dot filter, and we're going to say I, and it's going to be I modulus 85. Okay, I modulus 85 is equal to 0, and we're only going to limit it to 10. All right. So between 1 and 1,000, it's going to filter it to only the numbers that are divisible by 85, and it's going to limit it to 10. So it'll be multiples of 85. So 85, 190, 275, and whatever comes after that. Okay? Right. Now, so I can get the max of that. Now, so I can get the max of that. Now, the max of that is going to be, so I'll go back to main. $850. Okay, which is right. Goes up to 10 of them. So now I can't get them in. So if I try to get them in, ints dot min dot get as int, we have a legal state exception. Okay, so we can get them in, can get the max, but this is a terminal operation. So it closes. Now, just talk about the exam. I had to look at 1 or 2 stream questions. Now, they don't seem to expect you to know all of the methods. You couldn't because there's so fucking many of them. All right. But what they're generally asking for you with streams is, can you recognize when the stream is closed? Okay. So they'll have a terminal operation and then they'll have another terminal operation. There's a couple of those questions. They're the sort of questions they ask you to do with streams. All right. So you need to know when they're closed. Now, you can't possibly remember all of these methods. Jesus Christ. It's probably around 60 or 70 we've gone through. All right. Now, this is going to generate, and it might even tell you that max is a terminal operation as well. I saw one question, it tells you what the terminal operation is. All right. So we can get the max, but this is a terminal operation, so it closes the stream. So you can do no further operations on this stream. Okay. By the way, you can't use intermediate operators. So min is another terminal operation. You can't also do, so let's say I wanted to do I go ints dot filter. I'll filter that out to only even numbers. I go I modulus 2 is equal to 0. Okay, now that's an intermediate operation. It still causes an error. Okay, so you can't perform terminal operations on the stream or intermediate operations. Filter is an intermediate operation, it's not a terminal operation because the stream is closed. Okay, also can't do terminal operations on a closed stream. Can't do intermediate operations on a closed stream. Okay, now, but here we're talking about int streams, double streams, and long streams. Okay, now, so what we can use instead is we can use something called summary statistics. Okay, so we can use summary statistics to perform max, min, average, sum. I think there's also one called get count. Okay, we can use it to perform max, min, average, sum, get count. Okay, and these are not methods of the stream class, but a separate class entirely. Now, the three ones that we deal with are int, summary, statistics for Intstream, double summary, statistics for DoubleStream, and long summary statistics for long stream. Now, so it's a separate class entirely. And what it does is it gets information from the stream, right? Even now, so we'll create one. So I'm going to recreate ints. Okay. So that's going to produce 10 numbers and it's going to go all the way up to 850. Yeah? Now, so I'm going to create a separate object entirely. Okay? Now this object is going to be called int summary statistics. And I'm going to call it stats. Stat ints. So this is statistics dealing with our stats. Right? And it's going to be based on the ints Intstream. So it's going to be ints dot summary statistics. Now, I need to import this. Now, ints dot summary statistics is itself a terminal operation. Okay, so ints dot summary statistics is a terminal operation. So no more operations can be performed on the int stream. Now, however, this object here can be used to get the max of these guys. This object here can be used to get the min of these guys. This object here can be used to get the average of these guys. This object here can be used to get the count of these guys. This object here can be used to get the sum of these objects, these objects here. I'll just quickly show you one of them before lunch. So we go, the first one is count. Get count. So we go, how many objects have been produced? We can say count of ints is, so we go, it's stat ints dot get, see them all there? You've get average, you've get count, you've get max, you could get sum. So we're going to get count. Okay, the next one we're going to get max of ints is stat ints dot get max. The next one is min of ints is stat int dot get min. The next one is average. Stat int dot get average. Next one is sum. And the last one then is you can be producing streams. You don't know what type of stream it is. All right, that's going to happen. All right, a stream, because streams only take in if you have a stream of if you have a database that has strings in it, it's taking in that data type and it's putting it into a stream. The stream is going to be whatever type of data it takes in. That's the beauty about streams. Okay, whatever type of data it takes in, that's what the stream becomes. So it could be creating all sorts of exotic objects. So you're not, so it's going to, sometimes you're not going to know the class. So how do you get the class? You go class of object in the stream. Now this might not work. Let me just say stat int dot get class. Okay, similar statistics. Okay, that doesn't work as I thought it did. Right, so I'll just comment out that guy for now. So we have 10 objects. The maximum number is 850. The minimum number is 85. The average number is 467.5. The sum of the whole lot of them added up together is 4675. Okay, so these summary statistics are a way for you to get count, get max, get min, get average, get sum. Okay, now there is other summary classes that can do these things for streams as well, but I don't know how to do it. Okay, so there is a summary class as well for ordinary streams. Okay, now it's not on the exam, so I didn't look it up, but you can imagine you have a summary statistics for dogs, so it'll count the amount of dogs. It'll get the dog that's going to be the oldest. It's going to get the dog that's going to be the youngest. It's going to get the average age of the dogs. It's going to get the sum of the ages of the dogs. All right. Now, as I said, I haven't looked it up, but if you want to look it up yourself, fine. But we don't basically have the time to do it. All right. Now, go to your lunch. So when we come back, we're going to be doing, oh, wonderful, functional interfaces for primitives. Oh, these are joy. And then we have the last topic to do, was working with advanced stream pipeline concepts. And they're difficult. They're very difficult. All right, so we will get this whole chapter finished by Friday. Jesus. And so then we have to finish off chapter 3, because there was a bit left to do in it. And then we're going to start on dates and times and exceptions. So I will stop. I pause the share.